There we go. All right, so we've logged in to the SPSS software at myapps.mcewen.ca. So you sign in with your username at mymcewen.ca and your password, and then you select SPSS. So here is our SPSS main page. And here is the variable sheet that our data set will eventually be loaded into. So from the lab data file, let's work with the achieve data again today. So from our Blackboard page, you can download the achieve data set onto your computer somewhere. So let's just say we'll download it into downloads. We go back to our VMware. So to upload data, you click the up arrow, down arrow button. So this opens up the following page, so the transfer file page here. And we're going to click upload. So to upload, we'll click choose file, or you can just drag the file into the operator directly. So we'll click this achieve.save file. So this uploads it onto the VMware. All right, so let's keep that over here for now. And then if you open up the file explorer on the virtual machine, so this is basically your directory on this current machine, you can see that the achieve data set is now inside of documents. So if we go back to our SPSS page and we click open data file and we click open, we can select the achieve.sav data directly. So I'll just close the file transfer page for now so that we can see this. Okay, so here we have our achieve data sets. So you can see that this is a pretty small data set. We have 65 observations. We have the gender of each of the observations. So for today's lab, we're going to just go through a couple of different illustrations. Okay, so the first question, let's say, was just load the achieve data set into SPSS. So that we've finished. So now let's just go over a few of the basic things that we can do with SPSS. So let's go create, let me zoom in, sorry for everyone here. So create a table, or find a, use SPSS to create a table of summary statistics and provide a histogram of the data. Okay, so if we want to get a list of summary statistics from SPSS, here, I'll close this tab too. I'll just try and make this a little bit bigger for everybody. Ooh, it is so laggy today. All right, so we can go analyze, descriptive statistics, descriptives, or we can use explore. So descriptives or explore will both give you a list of summary statistics for the data set. I'll click explore for now because I like the output that's given in this particular table. So we click explore. We can click both display. We can click only statistics or only plots. Let's click both and see what it gives to us. All right, so we click both. All right, and here is our output. So you can see here in the descriptives table, we have a whole set of descriptive statistics for our data set. So it gives us the mean, it gives us a 90% confidence interval, it gives us the median, the variance, standard deviation, minimum, maximum, and a bunch of other statistics that are very in depth actually. So things like skewness and kurtosis, values that we don't really need, but it's a very thorough summary. And again, this summary here was found through analyze, descriptives. Wow, this is bad today. Okay, analyze, descriptives, explore. Okay, now I want to output this into my document. Yeah, that's correct, Sam. So I want to output this into my document. So there's a couple of things we can do. You can just copy and paste it. The thing that I don't really like about copying and pasting is that the output, oh, it actually didn't work here. So never mind. So we'll go export, and then we will go descriptives.doc. Okay, and then we'll save this here. Oh, sorry, file name. So this is one option to get the descriptive statistics into our Word doc. All right, and then if we go back, sorry, to our main page, just here, you can see that we now have descriptives located inside the documents icon. Okay, and then we can click upload, download, and inside download, we click Apple C. That moves the descriptives into here. We can download this onto our computer. And then when we open up this file, we will be able to copy and paste the descriptive statistics out of this file directly and into our Word doc. Yeah, that was going to be the other thing I was going to say. I just wanted to show this approach in case you wanted to do it this way. So the other approach, if you don't want to take that process of exporting, you can screenshot or trim the image. Okay, and then once you do that, it should save on your desktop. And inside of your machine, you can insert the image from wherever you saved it. So a picture from file, and then you can insert the screenshot. Okay, so that also works. Okay, so now we have some summary statistics for our data set. Yeah, everything I record will be posted on YouTube. Okay, so we have the two different ways of getting data into the into Excel or into our Word doc. You know, I think it's pretty clear that the screenshot one is probably the more efficient tool compared to the other approach. But the big thing here is just that when you're submitting your assignments, you just want to have everything laid out in the same document, so then you can export to PDF and you can upload that to CrowdMark directly. This will make marking easier. It'll also make organization of the assignments much easier. So here are our descriptive statistics. We wanted to produce a histogram as well. So you can see that the output from that file path creates a box plot for us, which is also useful, but we asked for a histogram. Sorry. Be so careful. Okay, so good stuff. This is already open. All right. Okay, so for the histogram, we would go graphs, legacy dialogues, histogram. All right, so then we would enter our variable name in here. We can click OK. And then we can title the histogram appropriately, actually by double clicking on said histogram. And you can see that this allows us to edit the axes directly, simply by double clicking on them. And we should be able to add in a title by right-clicking and choosing add title. So this will be histogram of scores. All right, and then again, screenshot here and move this into our Word doc. I wonder if there's a way for me. Yeah, sweet. That's what I was hoping. Okay, so we can also make some comments about these graphs inside of our Word document here. So first off, we can write a few comments about the descriptive statistics, for example. So the average score for the Achieve data set is 80.60. The standard deviation for the Achieve data set is 10.210. This indicates that the scores in the data set deviate by approximately 10 units from the mean. The histogram for the Achieve data set appears to be slightly right. Well, it's kind of tricky, right? Because so if we look at, yeah, it's slightly right skewed. So if we look at this histogram, we can see that if we were to kind of sketch the shape over it, there is a peak that appears kind of in the middle, right about here, but then we have another higher peak over here. So you see that there's a dive in the lower end. That would indicate to me a bit of right skewness, I think, in this illustration. Now we can verify that by looking at the median. So we can see that the median here is 81, which is only 15 units away from the maximum compared to being 21 units away from the minimum. This also indicates some slight skewness since the median is not equally spaced or is not equidistant from both the minimum and maximum. Okay, so SPSS for creating summary statistics and a histogram is pretty straightforward, as I mentioned. So we just have to follow those two paths. If we want to make some statements about the data set, we can comment on the skewness via the histogram, and then we can use the summary statistics to also help us understand what we're looking at. In this particular case, we're seeing an average score of around 80 plus or minus 10 units. So we have a standard deviation that's saying on average, our scores were between roughly 70 and 90 units. We also can say that there's a little bit of right skewness because the distance between the median and the minimum and maximum values are not the same. So skewness would be equidistant between min, or the distance between the minimum and the max would be the same as the minimum. Sorry, the distance between the minimum and Q2, the median, would be the same as the distance between the maximum and Q2, which is again the median. In this case, we can see that the median is a bit closer to the maximum, so that indicates some right skewness. Okay. All right, so calculate or use SPSS to calculate and interpret a 95% confidence interval for the population mean. All right, so hopefully you have all touched on the idea of a confidence interval at this point. The confidence interval, again, is essentially an interval estimate for the population quantity of interest. Yeah, it is left skewed. You're right. Thank you. Thank you. Thank you. Thank you. Thank you. That was a bad mistake. I've made a lot of bad mistakes this afternoon. I was having a hard time figuring out the difference between 102 and 96 earlier or something. Yeah. Don't compute after noon. Okay, so we want to use SPSS to calculate and interpret a 95% confidence interval for the population mean. So in the descriptive summaries that we have above in question 2 here, you can see that we actually are given the 95% interval directly. So we have 76.39 to 84.81. Okay, so we can say, from the descriptive statistics given above, a 95% confidence interval for the population mean is 76.39 to 84.81. Okay, so therefore, we can be 95% confident that the true mean average of the population mean score is between 76.39 and 84.81 units. Right, so pretty easy to pull the 95% CI out of that output. Let's use SPSS to calculate and interpret a 90% confidence interval for the population mean. Okay, just so that we can get an idea of how we would do a different style of interval. So to do this, we would go back to our achieved data set. We would click Analyze, Descriptive Statistics. Oh, sorry, one sec here. Okay, so we would do Analyze, we would do Compare Means, and we would do one sample t-test. Okay, so then we would admit the variable. So for now, we'll leave the test score at 0, but we'll come back to talk about that after. So inside options, so after we've selected our path, we've uploaded our variable, inside options, we would then change the confidence level to the level that we are interested in. So in this case, 90%. All right, and we would click OK. And you can see that our interval estimate is given in the lower tail, or in the second table shown here. So we have scores, we have the test statistic, degrees of freedom, the significance level, the difference, and then we have our confidence interval. So we can copy and paste this into our Word doc. Okay. Okay, and then we can say the 90% confidence interval for the population mean is between 77.11 and 84.09. Therefore, we can be 90% confident that the population mean score is between 77.11 and 84.09. So the confidence interval construction is actually quite straightforward when we just have to do it on its own. Let's look at, so verify the assumptions of the, or actually let's go construct, no, perform a one sample t-test to determine if there is evidence that the population mean score is greater than 75. Check and verify each assumption of the test. Okay, so let's use SPSS to perform a one sample hypothesis test now. So when we're doing this, we'll start off by listing our assumptions of the test. So the first assumption is that a simple random sample was collected. And the second assumption is that the variable of interest is normally distributed, or the sample size, yeah, we'll just say the variable of interest is normally distributed. I'll move this onto a new page. Okay, so for the first assumption, we don't actually have much information about the data set. So let's assume that this data is a simple random sample for illustrative purposes. But the truth is, to actually answer this, to address this assumption, we would need to know where the data came from, or we would have to have some idea of how the data was collected or where the sample came from. So, I mean, this is obviously just a data set that we have to illustrate some of the techniques in the class. So let's just assume that it's an SRS so that we can proceed with the problem. Now for the second part, when we go back and look at the data set in SPSS, you can see that we have 25 observations underneath score. So we don't actually know if the variable is normally distributed, but we can check it. So to check, we can use a QQ plot, which is the same thing as a normal probability plot. All right, so to do this, we will go analyze, analyze descriptive statistics, QQ plots. So you can see that some of the plots are in different locations within SPSS. We have some stuff in descriptive statistics. We have some stuff underneath graphs. So the QQ plots are in analyze descriptive statistics, QQ plots. Q-Q plots. Yeah. Okay, so we enter our variable. You can see under test distribution, you can actually compare to all different kinds of distributions. So we're just going to do normal. And I think that we're fine there. So we can click OK. And here's our QQ plot. Okay, so let's use this plot. I guess I'm copying the whole thing, but I don't really need to do that. Okay. All right, so here is our QQ plot for the data. Okay, so the QQ plot shows that the observations in the data set appear to follow a straight line relationship with the quantiles of the normal distribution. So what we're looking for when we use QQ plots is evidence of linearity. So we want to see if the observed value, which is placed on the x-axis here, so these are the values from our data set, form a straight line relationship with the expected normal value. So when we look at this plot here, this is the straight line between the values. And we can see that our points are pretty close to following that straight line. We have a little bit of a deviation here, but I wouldn't say that this data set appears to be drastically nonlinear. So we don't see like a really strong curvature like this outlined with my cursor or in the other direction. These appear to be pretty straight with the distribution or with the quantiles. This gives evidence that the variable of interest is approximately normally distributed. It would look like something like this is a good one. So you see this red curve here. So this blue part in the background. So these blue bars in the background, let them represent the linear relationship. Do you see how this red curve deviates from that relationship? That's what an example of what a non-normal relationship would look like. Sorry, guys, I got a direct message for that question. That's why I deviated there. Does that answer your question? Yeah, exactly. So if it's a linear trend, like what we see here, that implies normality. Exactly. Yeah. Okay, so now let's work through the hypothesis test. Okay, so on step 1, we have to declare our null and alternative hypotheses. So we want to test whether or not the population mean is greater than 75. So we're going to have H0, and then insert advanced symbol. We need a mu. And I need this one. Okay, so we're gonna have H0 mu less than or equal to 75 versus HA mu greater than 75. So as a reminder, when we're constructing a hypothesis test, our alternative hypothesis, so the HA part, this reflects the question of interest. So we want to test if the population mean is greater than 75. Or we want to test if there's evidence that the population mean is greater than 75. So the greater than 75 part is reflected through HA, which is given here. Okay. Yeah, it's fine. As long as it's organized and we can follow it, that's okay. Yep. So what you wrote, Sam, is good. Okay, on step 2, we're going to have alpha equals 0.05. So we'll have alpha. Well, we can declare whatever significance level we want. Let's just stick with the standard 0.05. Okay, now on step 3, we need to compute the test statistic. So in SPSS, we will select analyze, compare means, one sample t-test. So you can see the variable is already loaded. And then right here, we give our test value. So the test value is the population mean, which in our case is 75. Okay, and then we click OK. And then here is our output. Now, one of the things that you will notice about this output is it's a sig two-tailed. Okay, so what that means is the output from SPSS is always the two-tailed output, but we are only interested in a one-directional test right now. So after we insert our picture, right, so we have t equals 2.742. Right. So the output tells us that the significance level, sig here, is 0.011. So this value here is the p-value for this hypothesis test. And I'm just going to confirm. Yeah. Now this p-value here is for the two-tailed test, but we are actually conducting a one-tailed test. So the p-value for our test is going to be 0.011 divided by 2, which is 0.0055 roughly. So whenever we conduct a one-tailed test using SPSS, we always have to divide the outputted p-value by 2 because the p-value that is outputted will always be for the two-tailed test. So for the test of does not equal. Okay, so then on step 5, we can reject H0 since p-value is less than alpha. Does it matter that you still have confidence set as 90% even though the alpha is 0.05? No, it doesn't matter because when we go to make the our conclusion about the test, we only have to compare the p-value to the significance level, and the p-value is not affected by the confidence level. So you can have that set at whatever you want, and the result will be the same. The thing that matters is that we change that test value inside SPSS. So this is the most important part, but setting the confidence level won't make a difference in terms of our output. So for example, if I change this to 0.95, you can see that the result is exactly the same. Okay, and then we can say at the 5% significance level, the data provides sufficient evidence to suggest that the true or that the population mean score is greater than 75 units. Okay, so those are the main things that I wanted to show you guys today. Let's just talk a little bit about one of the results from the last 2 questions. So call this 6. Sorry, one sec. I'm really specific about this kind of stuff. Okay. All right, so compare the results from 5 and okay. So from 4, we have a 90% CI, which is 77.11 to 84.09. From 5, we have evidence that mu is greater than 75. Okay, so what can we learn from comparing these two results? Well, the first thing, okay, so when we are making comparisons between a confidence interval and a hypothesis test, one of the things that is important is that the critical value that is being used for the confidence interval and the hypothesis test is the same. So consider the formula for the 90% CI. We would have had just bear with me for a second here. Okay, so we would have had the following. Where is... Okay, if I can't figure it out, I won't waste too much time with this. But there is, oh, here it is. Okay. Okay, so we would have had X bar plus or minus T, and then we would have had to subscript here. Okay, so T, and then we would have had alpha over 2 comma n minus 1 and then this thing would have been multiplied by S divided by the square root of n. Okay, so our T value for the confidence interval that we computed in question 4 would have been a T on 0.01 over 2 comma n minus 1 where n is 25, so comma 25 minus 1, which is equal to a T value on 0.05 and 24. Okay, so the T value for the confidence interval would have been a T on 0.05 and 24. The critical value for the hypothesis test would have been the same. So okay. So this is important because when we are comparing the confidence interval and the hypothesis test, we would like them to be calculated using the same T value, so the same critical value. So for the upper tail test in question 5, our critical value would have been a T on 0.05 and 24. For the confidence interval in number 4, our critical value would have been the same thing. So now what we can do is we can compare them to see if the results agree. So when we compare number 5, which tells us that we have evidence that mu is greater than 75, and we look at question 4, which gives us the confidence interval 77.11 to 84.09. we can see that the confidence interval suggests that the possible values of the population mean score are between 77.11 and 84.09. Every value in this range is greater than 75. Therefore, the results of the hypothesis test and confidence interval agree. Okay. So I just wanted to talk a little bit about the relationship between the interval and the test. You can compare other confidence intervals, so you could compare the 95% confidence interval to the hypothesis test in question 5 as well. But there is a chance that if they don't use the same t-value, the results will disagree with each other or conflict each other. So ideally, when we make this comparison, we will use an interval and a test that use the same critical value, so that when we do that, we should see an agreement in the results. Why did you choose 75 for the hypothesis? It was I just picked a number randomly. I looked at the interval and I just picked a number that would work out for my example. Okay, so those are the questions that these are the examples that I wanted to give. So I just wanted to review again, uploading and downloading data, descriptive statistics, the histogram construction, and exporting documents from the virtual machine. The new things that I wanted to go over today were confidence interval construction and hypothesis test calculation. So you can see that for the hypothesis test, we can use SPSS to essentially perform step 3 and step 4. And for the confidence interval, we can use SPSS to do steps 1 and step 2. So if we were to write this out in a step-by-step process, we don't really need step 1 here because we don't necessarily have to write down the critical value. So it would sort of be like from SPSS, you kind of have a 2-step confidence interval. So you could write it like this if you wanted to. And then on step 2, you would just give the conclusion. So this is a confidence interval in a step by step formulation. And then the assumptions for the interval and the test are exactly the same. So if you had to verify the assumptions for the interval instead, you would do the same thing that we did below for the hypothesis test because they use the same set of assumptions. Okay, so do you guys want to see some more examples? Could we check this with a 95% CI? What do you mean, could we check this? Like this part, like the hypothesis test? Yeah, so if you wanted to compare 4 and 5 and use the 95% CI, what you would then want to do is adjust the significance level in technically, because of the way we're doing it, you could make the same comparison. So let's take a look at it for argument's sake, okay? So again, the main point that I was trying to make here was that when you compare a CI and a hypothesis test, you would like them to be built on the same critical value. So technically, we would need to adjust the significance level in order to compare the 95% CI. But let's say that we just took the 95% CI from question 3. Okay. So the 95% CI from 3 is 76.39 to 84.81. This also agrees with the result of 5 since every value in this interval is greater than 75. So it does actually work out in this case. This is the lab assignment that you're talking about? Yeah, so a point estimate for the population mean would be X bar. So for example, here in the descriptives where I have the statistic value, this value 80.6 is 80.6, that's X bar or the sample mean, and that is a point estimate for the population mean. Does that make sense? Okay. Can we try to do descriptive stats using the descriptive instead of the explore option? Yep. So calculate descriptive statistics using the explore option. Okay, so in SPSS, we'll go analyze, descriptives, explore. So you can see it's the same idea. You just move. Oh wait, sorry. Analyze, descriptives. Sorry, I don't know why it's giving me a really hard time right now. Okay. All right, so we can move scores over, click options here, and now we can actually pick what we want. So this summary will be a much tighter summary of the descriptive statistics. So let's keep the mean, let's keep standard deviation, let's add the range in, and we can do minimum and max. Click continue, click OK. Okay, so now we have our descriptives at the bottom here. So you can see that this is just a different output of the same values. But we can make almost the same conclusions that we could before. It's a little harder to talk about skewness in this case because we don't have the median, but we can still talk about the mean score and the standard deviation about those points. Is that okay, Chala, or did you have another question? Cool. No worries. Okay, so do you guys want to see some more examples of the hypothesis test or the confidence intervals? Do you want to see a different data set? Let's just say like at this point, I've shown you like I've shown you the materials that you need to complete the assignment. So I'll stick around obviously, and I'll keep answering questions and keep working through illustrations. And if you have any questions, like obviously stick around and let me know. If you think you've got it and you want to take off, that's fine too. You know, whatever works for you. So confidence interval again. So let's just do a different data set for, yeah, so the video and the Word doc will all be posted on Blackboard. Yeah. Okay, so confidence interval again. Let's do a different data set just for illustrative purposes. So file, sorry, losing my mind. Okay, so from the website, let's download the program.sav data. The first lab assignment should be due next Friday. Is it like Friday the 25th or something? Yeah, it should be due next Friday. Yeah. All right, so let's upload that data. Okay. So now we'll go open program. All right, not overly exciting. So let's build a 99% confidence interval for method 1, like, whatever. So analyze, compare means, one sample t-test. So we select method 1, and then we click options, and then we just change the confidence level to 99. Okay. And then we click continue, click OK. And then here's our confidence interval for that first part. Okay, so for method 1 from the program.sav data, build a 99% confidence interval. No, every assignment, lab, and lecture should be due on the Monday. Yeah, January 22nd, so Monday. Or every lab and lecture assignment should be due on a Friday at the end of the day. Yeah, so assignment 1 is due. Assignment 1 lecture is due today. Assignment 1 lab is due next Friday, and then it rotates. Yeah, unless, is there a reason why you guys think it was the 25th? Is that written somewhere? Okay. Course outline. Oh yeah, you're right. So it's they are due Mondays in the outline. Okay, so yeah, I'll just make it due Monday then. Yeah, so they're due on Mondays. That's fine. Sorry. I'll update that after class. Apologies. That makes more sense anyway, since we have lab on Friday, because it gives you the weekend. All right, so doing a few things at the same time here. Okay, so let's do it in a stepwise. So compute the CI. So we would insert picture from file, the latest one. Okay, and then we have 3.29, comma 6.35. And then on step 2, we can say we are 99% confident that the true mean value is between 3.29 and 6.35. Right, the bonus assignments. Yeah, so there's the other lecture has bonus assignments is basically the idea. Yeah. They're worth like an extra %, I believe. Something like this. No, I don't have them right now. I can do them though. It's just something that the other instructor was trying for the online teaching. You're not enrolled in CrowdMark. Sorry, I'm recording a lot of this, so I should probably just stop. Does anyone have any other questions about the intervals or the tests or anything like that? Shelby, did that answer your question about the interval? Sorry, so it didn't answer it? Okay, no worries. Yeah, mine's destroyed too. Okay, so let me just pause or stop the recording, and then I can try and help with the other stuff. Come on, Zoom.